Well, good morning, everyone. Welcome back from break into a new semester. All right, let's go ahead and get started on the lesson today. So, we are going to talk about um, factoring by grouping, and this is a technique that's used quite a bit. When do you use factoring by grouping? You usually use it when you have an even number amount of terms. But for what we're doing, we'll just say that 4 terms, but technically you could factor by grouping if you have 6 terms, 8 terms, depending on the polynomial. But for what we're doing in class, we'll just say 4 terms. And then this part made no sense to me. So you're going to look at here, notice it has 4 terms. 1, 2, 3, 4. You're going to look, is there a GCF and everything? Well, they all don't have an X, so I can't factor out an X. And I have a 1, a 6, a 5, and a 30. So the biggest number that goes into 1, 6, 5, and 30 is 1. So this does not have a GCF. Okay. Here, do they all have an X? No. Is there a number that goes into 12, 2, 30, and 5 besides 1? No. So there is no GCF here. Here, do they all have an X? No, this one does not have an X. Is there a number that goes into 8, 64, 1, and 8 besides 1? No, so there is no GCF. So really this first step, factor out the GCF if there is any. Usually there isn't a GCF. You're going to group the first 2 terms and group the last 2 terms. And then be sure to group the signs as well. And then you're going to put the groups together. You're going to factor out the GCF from both groups. And then whatever you have left from factoring, they should be the same. So we'll start with this first example. Okay, so sometimes I've seen it helps to just look at the left side. So notice I covered up the right 2 terms. So I look at x cubed plus 6x squared, and I ask myself, what is the GCF of x cubed plus 6x squared? So this is what we call factoring by grouping. So what we're going to do is we're going to factor these 2, and then we're going to factor those 2, and then we're going to see, hopefully they have a common factor. When I look at x cubed plus 6x squared, I should notice that the GCF is x squared. So I'm going to take out an x squared. And then I'm going to write down what's left over. If I take x cubed and I divide out an x squared, that leaves an x. And if I take an x squared and divide it by 6x squared, or I should say 6x squared divided by x squared, that's left with a 6. Checking my work, x squared times x is x cubed. X squared times 6 is 6x squared. So I factored my left 2 terms. So now I'm going to cover it up and try to factor the right side. Now the right side, anytime there's a negative, you factor it out. And when I look at 5 and 30, the greatest common factor of 5 and 30 is 5. They both don't have an x, so I'm not going to factor out an x. Now what's left over, negative 5 times what is negative 5x. I need one more x. And then negative 5 times what is negative 30? That'd be positive 6. So now let's look at the whole thing together. So I factored the left two sides, or I'm sorry, the left two terms, and I got x squared x plus 6. I then factored the right two terms, and I got negative 5x plus 6. Now, if these are the same, which they are, then we could take this one further step. If they're not the same, then that means either you messed up, maybe you can't factor by grouping, or sometimes you need to rearrange the second and third term, and maybe that'll have a common term. So since they both have an x plus 6, you factor out x plus 6. And then what's left over is x squared minus 5. So I just factor this from a cubic down into a linear term, and that's also a quadratic term. If I were to multiply this out, x times x squared is x cubed. X times negative 5 is negative 5x. 6 times x squared is 6x squared. 6 times negative 5, negative 30. Now, technically, we want linear terms. This is a linear term. This is going to go back to last semester. But if you have difference of two squares, so this is x and x, and I can make that square root of 5, square root of 5, I could actually factor this into x plus square root of 5, x minus square root of 5, and then I could bring down my x plus 6. So what that means is if I needed my solutions are negative 6, negative square root of 5, positive square root of 5. Now let's say I want to check my work and I'm like, I mean, I could distribute all of this out. Let me show you. So if I type in this cubic and I type this in, I should get the same graph, and I'll show you that. Let's see, Desmos. So this is just a quick way to check your work. If I type in x to the third, what was it, plus 6x squared minus 5x minus 30. Notice because it's to the third power, I have 3 solutions. They're all real solutions. That's what also we talked about last semester. And now if I type this in factored form, square root of 5, oops, and then x. And if you type in SQRT, see how it makes the square root, and then 5, notice that they are the same thing. They're just different forms. So I know without a doubt that this is correct. One solution is at negative 6. See it? One solution is at negative square root of 5. If you type in negative square root of 5, you will get negative 2.236 as a decimal equivalent. And then here you got positive square root of 5, which is 2.236. See? So that's one way you could check your answer. Let's try another one. So we already checked for GCF of the whole thing. I cover up my last two terms. I ask myself, what's the GCF of 12 and 2? Would be 2. What's the GCF of x cubed and x squared? It would be the highest exponent, or I'm sorry, the smallest exponent. So that would be x squared. So I just found the biggest term that divides into both of these would be 2x squared. Divide it out, see what's left. 2 times 6 is 12. X squared times what is x cubed? I would need one more x. Bring my plus over. 2 times what is 2? I could put a 1. You don't have to. And then x squared times what is x squared would also be 1. Now I have to at least put a 1 there to hold the spot. So notice that 2x squared times 6x is 12x cubed. 2x squared times 1 is 2x squared. I then look at the right side. And they both don't have an x, so I can't factor that out. But 30 and 5, and anytime there's a negative out front, you factor it out. What is the largest number that goes into 30 and 5? That would be 5. Now, what should be left over is 6x plus 1 because we want those to be the same. But let's just double check. Negative 5 times what is negative 30x? I would need 6x. And then negative 5 times what is negative 5? That'd be plus 1. So notice these are the same. So I factor it out. If they are not the same, that usually means you messed up somewhere. And then I also have my 2x squared minus 5. Okay. So I factor out 6x plus 1, and then I have my 2x squared minus 5. Just like on the last one, I factored out my x plus 6, and I was left with an x squared minus 5. You could break this down, but you usually don't see that broken down with the 2 right there. So I think we'll just let it be. Even from here to here, not everyone always breaks those down. At the very least, I need you to get to this first step. All right, next one. Cover up my last 2 terms. And I ask myself, what goes into 8 and 64? The largest number, that'd be 8. What's the largest number, or I'd just say the smallest exponent between x cubed and x squared? That'd be x squared. What's left over? If I take 8x squared out of 8x cubed, all I need is 1 more x. Because 8 times 1 is 8, x squared times x is x cubed. And then bring down my minus. 8 times what is 64? That'd be 8. And then x squared times what is x squared? We don't need anything else. And then I factor the right side, and I say, what does, and I need to bring down the plus here, sorry. What does x and negative 8 have in common? Well, they don't. But everything always has 1 in common. 1 goes into x, 1 goes into 8. So we're going to factor out a 1. And so because we didn't change anything, it's just going to stay x minus 8. Because 1 times x is x, 1 times negative 8 is negative 8. From there, they're both x minus 8, so I factor it out. And then I have my 8x squared plus 1. And then usually this will factor some more. It just so happens that for that, I mean, I guess I can make that square root of 8x. We're not going to do that. Okay. So that's factoring by grouping. Let me, I have out there on the page more examples. So if you go out here, so just more examples you could read through. They're already worked out. So notice how there's 4 terms. So they broke it in half. And then they looked at the left and they saw that x cubed plus x squared had a GCF of x squared, leaving x plus 1. And then here 2x plus 2 had a GCF of 2, leaving x plus 1. So then you get x plus 1, x squared plus 2. Here they did the same thing. They wrote down the problem. They broke it in half. They looked at the left, so they looked at those two, and they said 6 and 9, GCF is 3, x cubed and x squared, GCF is x squared. That leaves 2x minus 3. Here they looked at 4x minus 6. They took out a 2. That leaves 2x minus 3. So notice how both of those are the same. So you get 2x minus 3, 3x squared plus 2. And so if you go out there, I'm not going to read through every single one of these. Now, here's a good example. Notice when they got to this step, they got x plus 1, and here they got x minus 1. So since those are not the same, there's nothing else you could do. You have to stop. So either you messed up and you need to check your work, or just like in this problem, it's just not factorable. Okay. These 4, if you want to try, those are the answers. But notice there are a lot of examples. Now, some problems like on C, when you get to this step, notice because we factor out an x plus 1 and we're left with an x squared minus 1, that x squared minus 1 factors in the x plus 1, x minus 1 difference of 2 squares. Okay. So there's plenty of more examples there. I also want to point out that we are in the middle of a unit. So if you go out to your modules, you'll see that I uploaded the lessons from last semester that will be on the district assessment. And so if you go out there, some things we learned was about end behavior, multiplicity, another day about multiplicity, how to find the total number of solutions, how to sketch a graph, how to find the GCF. We talked about quartic trinomials. And so on the first district assessment, which in case you haven't seen, I think I have the whole unit out here. So January 14th, we're going to take that first district assessment. So notice we're covering grouping today. I'm going to cover something new on Friday, and then we'll review, and then you'll take your assessment. But what's important, I think, is to know that there is some stuff from last semester. It's the stuff we did but never tested over. It'll also be on the test. All right, other than that, what should you turn in to me? I know I have a couple new students. If you go underneath the page, so today's January 6th. Our target was factoring by grouping. I will be signing off here shortly. If you have any questions or you want to have a one-on-one conversation, you would click this Zoom link. It takes you to a waiting room, and then I will answer any questions you have. I'm there from 8 to 8:30. The bell work, I highly encourage that you do it. It's only supposed to be 5 minutes. I do not have you turn it in. It is just for your own good to practice ACT. Okay, all of these questions came from the ACT. Normally on exit slip, I have some sort of discussion. Probably for now, I won't have those out there. I think I'm going to leave those off for now. I will usually have notes that I feel are good. Here's the 3 problems I did together. These 3 are not factoring by grouping, so I decided not to do those. Those are a review, and we don't really have time for that. And then notice these are not me, but they are people describing how to factor by grouping. And I put the stuff at the bottom that you need to do on purpose because you're supposed to look at the stuff on top. And so if you go out to the practice, and practice counts for 20% of your grade, notice I have factoring by grouping. Now you may be asking, wait a minute, you didn't show one this complicated. And that's true. But notice in this step, they already have the 3b minus 1. So you factor out the 3b minus 1, leaving 2a plus 7 plus 3a minus 2. So, so these are already almost factored for you. The ones that are really important are 5 through 8. And then here's some more examples. Okay. So that's what you're going to turn in to me. The way to turn it in is you submit your assignment. You could print this off, take pictures, or see how it says annotate with Kami. That's also a good way. So like you could open it up. And then number 2, I'll show you this one because it's kind of tricky. So because they all have a 2x minus 1, I can factor that out. And then what's left over, what would be left over would be the 3x plus 4 plus 2x. So we're already at that step is all it is. And then we see that 3x plus 2x, because they're in the same parentheses, I could combine those. That'd be 5x plus 4. Okay. And then you could just drag it in there or whatnot. So Kami is a good program you could also use. Let's see, I don't really want to save mine. There we go. Delete. Okay. And then finally, when you're done with your practice, you have a quiz that's worth 80% of your grade. I have it worth 80%, but the district assessment really is your grade. So it's not just about turning stuff in, it's about understanding. I have that worth 10 points. I need to go fix that real fast, but I'm trying to set these equal to 20 points this semester. And I have it here to give you 3 chances. So don't start the quiz yet. Give me like 5 minutes to fix that. But other than that, that's all I have. You're supposed to do the practice and the quiz. I'm going to sign off of here. And then at 8 o'clock, I'll sign into office hours. If you have questions or you get stuck or you need to see more examples, feel free to join. But other than that, it's nice seeing you. Nice meeting a couple of you. And I'll be signing off here. Bye-bye.